Hello everyone, this is Teacher Harold, your junior high school mathematics teacher, and in this video, I will discuss the second part of the lesson in Mathematics 9, and this is solving problems involving quadratic equations, particularly distance, time, and rate problems, and word problems. So, at the end of this video, you are expected to translate worded phrases or sentences to mathematical expressions or equations and solve problems involving distance, time, and rate together with work problem. In this material, you need to use the skills you gained in solving quadratic equations using any appropriate method, which was discussed in the previous lessons, together with your skill to translate verbal phrases or sentences into mathematical expressions or equations in order to solve word problems related to quadratic equations. Let's begin with our discussions in this next slide. The distance, time, and rate problems. So, for our first example, on a journey of 100 kilometers, Jim travels at a certain rate for the first 60 kilometers and then increases his rate by 15 kilometers per hour for the remainder. The whole journey takes him 2 hours. What is his rate on the remaining 40 kilometers journey? So for our solution, we will apply the formula relates to distance, rate, and time in physics. Now, according to this science subject, the distance is equivalent to the product of the rate or speed multiplied by the time. So, if we're going to transform this formula solving for time, that is equivalent to the ratio of the distance traveled to the rate. And of course, as we all know, as stated in the problem, the total time of travel of Jim is 2 hours. Now let us have the first part of our solution, and that is representing the unknowns involved in the problem by symbols. So let's just say we represent the symbol R for the rate or speed of Jim for his 60 kilometers trip. And of course, this is his slower speed during the 60-kilometer trip. And then the second speed for the remaining 40 kilometers is denoted as R plus 15. And I think if the first speed, if this is the slower speed, then R plus 15 is his faster speed. Okay, and this is his rate for his 40-kilometer journey or trip. And of course, this is also known as the faster speed or rate. Then, the next step is to translate the given condition to mathematical equation. That is, from this situation, time at the slower speed plus the time at the faster speed is equal to the total time. Now, from this situation, we can now formulate or transform or translate the equation. And of course, we use this formula. So we're going to express the time for both terms in terms of the ratio of the distance and the rate. So, for the first term, for the time at a slower speed that is equal to 60 kilometers traveled divided by his slower speed, which is r, plus the time at a faster speed that is equal to his remaining 40-kilometer trip divided by his faster rate, which is r plus 15. And since the total time of journey or gym is 2 hours, so this expression is to be equated to 2. And as a result, the formulated or translated mathematical equation is actually a rational algebraic equation which can be transformed to quadratic equation in standard form. So for the next step, upon formulation of the equation, we're going to solve this. And in order to do that, we need to transform this equation to standard form. And these are the following steps. First is we determine the LCD of these two denominators. So basically, the LCD is simply the product of r and the quantity r plus 15. And that is the LCD. So what shall we do with the LCD? We're going to multiply this formulated equation by the LCD to both sides in order to clear the denominators. So, taking this equation and multiply both sides by the LCD, which is r times the quantity r plus 15, the equation will be like this, wherein each term is being multiplied by the LCD. Okay. Then what will happen next is that since each term is being multiplied by the LCD, the denominators are now to be cleared out. Okay, so may cancellation na mangyayari. R here will be cancelled as well as this denominator r plus 15 will also be cancelled out. And what will remain from the equation is now an equation free or cleared from the denominators. And the equation is 60 times the quantity r plus 15 plus 40r equals 2r times the quantity r plus 15. Then perform the indicated operations. So on the left side, we distribute 60 to each term inside the parentheses. Same thing with 2r, which is also to be distributed to each term inside the parentheses. And the resulting equation will be like this. And then, if there are similar terms on one side, we need to combine them, and that is 60 plus r, 60r plus 40r. So the left side becomes 100r plus 900 equals 2r squared plus 30. And then we transpose these two terms to the other side and combine similar terms. So at this point, we have now the equation 0 equals 2r squared minus 70r minus 900. And we apply the symmetric property of equality. The equation becomes 2r squared minus 70r minus 900 equals 0. And we simplify further the expression on the left side. We divide each term by 2 so that the final equation in standard form would be r squared minus 35r minus 450 equals 0, which is now in standard form. And from this form, we can determine the values of a, b, and c. And these are 1, negative 35, and negative 450 respectively. Now, upon declaring those values of a, b, and c, we are going to apply the quadratic formula so that we can solve this equation. So, plugging in the values of a, b, and c to this formula and compute for the value of r, we will obtain two answers here. Okay. Of course, upon substituting the values, we simplify the resulting expression applying the GEMDAS rule or the PEMDAS rule. And the resulting expression will result to two values of R. The first value is the one wherein the negative square root is being considered. So that is 35 minus 55 all over 2, or R, which is 35 plus 55 all over 2. So the two values of R are, the first one is negative 10 and the other value of R is 45. Now, since we are looking for the speed, which is always positive, it means the only value of R that is acceptable here is R, which is equal to 45, and we cannot consider the negative answer, which is negative 10. So therefore, the slower speed of Jim is 45 kilometers during the 60 kilometers trip, and his faster speed is can is 60 kilometers per hour, which is taken from the expression R plus 15 by plugging in the value of R, which is 45. So, his speed for the remaining 40-kilometer journey is 60 kilometers hours, 60 kilometers per hour, and this is the answer. For our next example, number 2, we will go to the next slide. A jet flew from New York to Los Angeles, a distance of 4,200 kilometers. The speed for the return trip was 100 kilometers per hour, faster than the outbound speed. The total trip took 13 hours. What was the speed of the jet from New York to Los Angeles? So again, we use the formula from physics, which is related to time, distance, and rate. And the formula is time is equal to distance over rate. Now, in this problem, the first part is again, we represent those unknown quantities by symbols. So let's just say we denote V, the speed from New York to Los Angeles. And V plus 100 be the speed from Los Angeles to New York, since this is the returning trip whose speed is 100 kilometers faster than the first one. The speed which is uh, traveling with the speed that travels from New York to Los Angeles. Now, we go to the next part, which is translating the conditions to mathematical equations. Now, we use the formula in physics, this one, time is equal to distance over rate. Since the distance between the two places is 4,200 kilometers, we have time from New York to Los Angeles plus the time from Los Angeles to New York has a total of 13 hours. And expressing the time in terms of the ratio of the distance over rate, from each term we have 4,200 divided by B plus 4,200 divided by the quantity B plus 100 equals 13. And at this point, we have just formulated an equation which is actually a rational algebraic equation which can be converted to or transformed to quadratic equation in standard form. So the next step is we're going to solve this equation by first transforming this to standard form. And for us to do that, we need to clear the equation from the denominator. So we need to determine first the LCD. And that is the product of the two denominators, b times the quantity b plus 100. And this LCD is to be multiplied to each term on both sides from this equation. And this is the result. And since each term is now being multiplied by the LCD, okay, the equation will now be cleared from any denominator. So b will be cancelled as well as the quantity b plus 100. And what will remain from the equation is this. 4,200b plus 420,000 plus 4,200b equals 13b squared plus 1,300b. Now, we do some transposition of terms and combine similar terms. So we have now this quadratic equation expressed in standard form. And from that form, we could declare the values of A, B, and C, and these are 13, negative 7,100, and negative 420,000 respectively. Of course, the reason for declaring those three values is we're going to solve the equation using the quadratic formula. So we just plug in the values of A, B, and C to this formula and simplifying the resulting expression using the PEMDAS rule. Now, upon simplification, again, we obtain two values of B. And these are what? The first value is 600, while the other value is negative 700 over 13. And obviously, the value that we can only consider is the positive result and not this one for the speed or the rate. Now, since we only consider the positive result, we have V which is equal to 600 kilometers per hour. And this is the speed of the jet traveling from New York to Los Angeles. And obviously, ito yung sagot. Okay, or this is the answer. The next part of this video is the discussion of solving another type of word problem. And this is the work-related problems. So let us immediately go to the first example. Now suppose there are two pipes working together can fill a tank in 35 minutes. The larger pipe or the large pipe alone can fill the tank in 24 minutes, less than the time taken by the smaller pipe. Now, what is being asked from this problem? Most probably, how long will it take for each pipe alone can fill the tank? Okay? So I think that is what the problem is asking for. That the time for each pipe to work alone to finish the task, which is filling the tank. So, the first part of our solution is the representation of the unknown. So let's just say we denote the symbol X for the time in minutes the smaller pipe can fill the tank alone. And for the larger pipe, we have X minus 24 be the time in minutes the larger pipe can fill the tank alone. Why is it X minus 24? Because according to the problem, the larger pipe alone can fill the tank in 24 minutes less than the time taken by the pipe. And that is how we translate it by this expression, x minus 24. Next, we translate. Now, for every minute, the smaller pipe alone can fill 1 over x of the tank, and the larger pipe alone can fill 1 over the quantity x over 1 over the quantity x minus 24 of the tank. So, but if these pipes are both open, for every minute, they can fill 1 over 35th or 1 over 35 of the tank. So, for the equation, we have 1 over x, this one right here, added to 1 over the quantity x minus 24 equals 1 over 35. As a result, we have another case of a rational algebraic equation transformable to quadratic equation. So, at this point, we can now solve that equation by first transforming it to standard form. So, we need to change it again to standard form by first determining the least common denominator. Now, since we have three different denominators, therefore the LCD is 35x times the quantity x minus 24. And this LCD is to be multiplied by each term of this equation to both sides. So again, LCD multiplied to each term of this equation on both sides. So, multiplying this LCD to both sides of the equation, so we have what? Again, rewriting the equation, but in this particular case, each term is now being multiplied by the LCD. And because of this, the equation is now to be cleared from any denominator. So x will be cancelled together with quantity x minus 24 and 35, so that the equation becomes what? 35x minus 840 plus 35x equals x squared minus 24x. So we combine similar terms and do some transposition of terms. Therefore, the equation is now transformed to standard form. And this is x squared minus 94x plus 840. A quadratic equation now in standard form. And we can now solve this using factoring, because this expression right here is factorable. And the factored form is what? Quantity x minus 10 times quantity x minus 84 equals 0. So since we use factoring here, upon getting the factored form, we equate each factor to 0 using the concept of zero product property. And we have two resulting linear equations in one unknown. So we have x minus 10 equals 0, and the other one is x minus 84 equals 0. So the two values of x are 10 and 84. So, between the two, we can only accept 84 and not 10. Why? Note, this is the reason. Note that x, which is equal to 34, is the answer because x minus 24 will give the result of 60. The other root, which is x equals 10, will not give us the answer we're looking for, since 10 minus 24 will result to negative 14, which happens to be the time in minutes the larger pipe can fill the tank alone. So there's no such thing as negative answer in terms of time or in terms of number of minutes for the larger pipe to fill the tank alone. So therefore, the answer is 84 minutes and 60 minutes for each pipe can fill the tank working alone. Probably this is for the larger pipe and 60 minutes for the smaller pipe. So again, I'm sorry, sorry. I stand it correct. Okay. This is for the smaller pipe. The number of minutes for the smaller pipe to fill the tank alone. And 60 minutes is the time for the larger pipe to fill the tank alone. Okay, so next, for our second problem under this work-related problems, Jason and Roger working together can paint a school canteen in 3 hours and 36 minutes. That is equivalent to 3 hours and 3/5 of an hours. 3 and 3/5 of an hours of an hour, or 3 and 3/5 hours. Okay. Working alone, it takes Roger 3 hours less than what Jason to do the job. How long would it take for Roger to do the job alone? So for our representation, we let P be the time in hours for Jason alone to do the job, while we denote P minus 3 be the time in hours for Roger alone to do the job. Then for the translation, for every hour, Jason alone can paint 1 over P of the canteen, while Roger alone can paint what? A portion of a canteen, which is 1 over the quantity P minus 3 in every hour. So if they work together, okay, they can do the job working together for 3 and 3/5 hours. So, take note, 5 over 18 is the reciprocal of 18 over 5, which is actually 3 and 3/5. So, formulating the equation, 1 over P plus 1 over quantity P minus 3 equals 5 over 18. And this is, again, a rational algebraic equation transformable to quadratic equation. So, solving this rational algebraic equation, we have to again change it to standard form. But first, we identify the LCD, and that is 18P times the quantity P minus 3. And this LCD is to be multiplied to each term from this equation. So, again, just like the previous problem, for each term, it is now being multiplied by the LCD so that we can clear the denominators from this equation. Okay, canceling P minus 3 and 18. So the equation becomes 18P minus 54 plus 18P equals 5P2 equals 5P squared minus 15P. And then we do some transposition of terms and combine similar terms. The equation is now expressed in standard form, and that is 5P squared minus 51P plus 54 equals 0. Where A, B, and C are 5, negative 51, and 54 respectively. So obviously, the method to use in order to solve this equation is the quadratic formula. Now, plugging in the values of A, B, and C and simplify the resulting expression using the PEMDAS rule, so we will have the two values of P. The first one is 51 minus 39 all over 10, and the other value is 51 plus 39 all over 10. So the first value is 6 over 5, and the second value is 9. So this one right here, which is equal to 9, is the acceptable value B, and not this one, 6 over 5. Why is that? Because P, which is equal to 6 over 5, will result to negative value for the expression P minus 3. Okay. So, P, which is equal to 9 hours, is the time for Jason to do the job alone. While Roger can finish the job for 6 hours. So that is taken from P minus 3, where P is replaced by 9. So 9 minus 3 is 6 for 6 hours. Therefore, Roger can do the job alone for 6 hours. And that is the answer. Okay? And that will be all for now. See you next time.